Yes, same the guy. Today let's talk about tetracyclines. Yeah, as we are starting this video, please don't forget to subscribe, like the video, share to all medical students. What you're going to talk about, we are going to talk about the introduction, the general structure of the tetracyclines, nomenclature, classification, some of the chemical properties, stereochemistry. All these ones are under chemical properties: stereochemistry, pKa, chelation, epimerization, dehydration, lactonation. We talk about the mechanism of action, resistance, chelation incompatibilities, the SAR, therapeutic applications, the adverse drug reactions, contraindications, drug interaction, and specific agents. Yeah, now let's begin with the introduction. Tetracyclines, one, they are broad spectrum. They are broad spectrum antibiotics. They act on gram positives, gram negatives, aerobes and anaerobes. They also have the action on the mycoplasma, rickettsia, and many other organisms, including some of the protozoa infections. They are yellow in color. They are bitter. So most of them, they are formulated as capsules because of the bitter taste. Bitter taste. Tetracyclines, they are also labile to light. So light destroys these tetracyclines. So they are lightly labile. The tetracyclines, some of them are obtained from natural sources, those Streptomyces species by fermentation, and also by chemical modifications of the natural tetracyclines. Some of them are semi-synthetic and others are synthetic. So we can get them by semi-synthetic methods. And some of them are synthetic, like tetracycline. They are used in human and veterinary and human. Now let's talk about the general structure of these tetracyclines. Tetracyclines, they have the general structure. The pharmacophore is octahydronaphthacene ring structure. It's a 4-membered ring structure having these 6-membered rings. It is octahydronaphthacene. It's called octahydro because it has 80 saturated carbons, as we are going to see. So the first ring is fully unsaturated. The second ring is, we have a double bond here and here. So when you count, here we have OH, here we have O, here there is OH, here there is O, and here we have also an OH group. Here there is an amide group, OH. Here there is a dimethyl amine group. So when you count these carbons, the saturated carbons, they are 8. That's why it's called octahydro. We start from this one. This is 1. This is 2, 3, 4, 5, 6. We have 7 and 8. So those are the 80 saturated carbons. That's why it's called octahydronaphthacene ring. Because for the naphthacene ring, all these bonds are unsaturated. All the rings are unsaturated. So this is the general structure for all the tetracyclines. What changes is only these groups here. Here we can have, let's call this one R1. This one will be R2. This one will be R3. This one will be R4. So what changes? It is these groups. one of those groups, and you find some of the tetracyclines, they have a substitute here at this position 9. So this is position 1, 2, 3, 4. This is 5, 6, 7, 8, 9, 10, 11, 12. Those are the 12. Then these positions, they are numbered. If this one is 4, this one will be 4A. This one is 5, this one is 5A. 6, 6A. Like that. All these ones. This one will be 12A. This one is 11A. So this is the general structure for tetracyclines. Now, when it comes to classification, for classifications, tetracyclines can be classified in different ways. We can classify them in the convention classification, where we have the first generation. In the first generation, we have those tetracyclines which have the OH group at position 6. Here we shall find the oxytetracycline. Oxytetracycline. We find the tetracycline itself. We find the chlorotetracycline. And many others, those which have the OH group here at position 6. Then when it comes to the second generations are those tetracyclines where this OH at position 6 was removed, where we have the doxycycline, the aminocycline, and some they have OH groups here, but they modified them at this position at the amide region, where we have the rory-tetracycline. And many others. Then in third generation, we have the tetracyclines which we are modified, or the fully synthetic. For example, the tigecycline. We shall see all those modifications, why they remove this OH group to make these ones, why they modify this one to make the tigecycline. This is one of the classification. We can classify them according to the source. According to the source, we may have the synthetic one or the natural tetracyclines. For example, the tetracycline. We have the chlorotetracycline. We have the dimecrocycline. This one was gotten from the streptomyces or your fashion. This one. Then also this one was gotten from streptomyces or your fashion, though sometimes it is gotten from the modification of the chlorotetracycline. Then the dimecrocycline, this one is gotten from this species by the mutated one. Mutation. The mutated species of the streptomyces or your fashion. Then there is oxytetracycline. This one is gotten from the streptomyces remosus. So these are the natural tetracyclines. Then we have the semi-synthetic ones. Here we have the doxycycline. Doxycycline. We have the aminocycline and many others, for example, so the tetracycline. Then we have the fully synthetic tetracyclines, the synthetic ones. Here we have an example is the tetracycline. Is the tetracycline. So that's all about the classification. Now I've skipped the nomenclature, but let's talk about nomenclature now.